So Emma, we can now go to number 10, number 10, number 10, part A, number 10, part A. So it is saying given the points, we have points as P, this is 5 and negative 3, 2 as negative 6, 1, then R as 1, 8. So they want us to show that when you get this P, H and R, they form a triangle. They want us to show that these 3 points, when they are on the vertices, they form, or when they are the vertices, they form a triangle. So it means that they want us to show whether if this one is a triangle, if it is a triangle, if P, Q, R forms a triangle. So it means here there is a condition we have to fulfill. There is a condition we have to fulfill. So for a triangle to be a triangle, we say that when we get the sum of two distances, let's say if we have a distance P2 and distance 2R, okay? So we have distance P2 and distance 2R. So when we add these two distances, the sum of these two distances should be greater than the distance, or should be greater than the distance of the remaining side. So the remaining side here is RP. So which means that the condition that makes a triangle, it means that when you get this distance from here to here and you add a distance from here to here, these two distances their sum should be greater than the distance here. Are you getting it? Let's say like here is 3, this one is 6, this one is like 4. It means that when you get 3 plus 6, it is equal to 9, not so. So this 9 should be greater than this distance here, should be greater than 4. So when this distance here and here is greater than 4, we call this one a triangle. But whenever you find that after adding these two distances, you have still this side being greater than these two distances, that one cannot be a triangle. It becomes something else. So it is the condition that you're going to prove. So we can start by finding the distances. So we look for the distance. So we begin with the distance P2. So getting the distance P2. So getting distance P2, remember they have given us P and 2, not so. Just using the other formula we had up, the formula was for getting the distance was x2 minus x1 squared plus y2 minus y1 squared under a root. So remember we have this one can be x1, we want P2, the distance from P to 2. So it means this one will be x1, y1, x2, y2. So I come and I feed in here. So when I feed in here, I have my x2 as negative 6, then minus x1, which is 5, and this one is squared, then plus y2 is 1, then minus y1 minus 3. You see that squared. I think we are together now. See, this one was y2, which is 1. Then minus y1, which is minus 3. So minus 3. Wow. Then this one is under the root. Then this one will be giving us what? Minus 11 squared plus, this one becomes plus, which is 4 squared under a root. And this one will be giving us what? What is 11 squared? 11 squared is 121. Then plus what we call, this one is 16 under a root. So what do we get here? We get root 137. Next we have to get the distance 2r. So distance 2r, we still have 2, we have r. This one can now become our x1, y1. Okay, let me write the points here. I have 2, 2 was, they told us it is negative 6, 1, then r is 1, 8. So I want the distance between these 2 points. So this one can be x1, y1, x2, y2. So the distance here, it will be, now remember we said it is x2 minus x1. x2, which is 1, minus x1 minus 6 squared, then plus y2. You see y2 here? y2 is here. This is 8 minus y1 minus 1, which is squared, under a root. So we'll be giving us what? This is 1 plus 6. 1 plus 6, which is 7 squared, plus 8 minus 1, which is 7 squared, isn't it? Yes. Under a root. This one will be giving us what? 49 plus 49 squared under a root. So what will be the answer? The answer is root of 98. So now we can go to distance RP. So now distance RP, oh, it is losing focus. Okay, now we're together. Distance RP, distance RP. Remember we said R is what? R is, let me check back here. R is 1, 8, and then what is P? P is 5, negative 3. So P is 5, negative 3. This is R, this is P. So this one can be my x1, y1, x2, y2. So I substitute in our formula. So distance will be equal to y2 minus y1 is negative 3 minus 8 squared, then plus x2, which is 5, minus x1, which is squared, under root. Then this one will be giving us what? Negative 3, negative 8. It becomes negative 11, isn't it? Squared. Then plus 5 minus 1, which is 4, squared, isn't it? Yes. So under root, what do you get here? Remember this one, we said it is 121. Then this one is 16. We got something like this. I think somewhere here. You see? So it is giving us the same distance. So this one is root of 137. Okay. So we have all the three distances. We have RP, we have 2R, then we also have P2. So now, remember we said our condition has to be that when we add two sides, let's say P2 plus 2R, it should be greater than RP. And indeed, when we get P2, which was root 137, so we shall say since P2, then plus, what was next here? Next here was 2R plus plus 2R is greater than RP, and it is true because we got P2 as root of 137, not so? Then plus the root of 98. It should be greater than RP, which is root of 137, and it's true because we already have 137 here. So this side is 137, the root of it plus 98, and it is greater than this. So therefore the points form what? The points P2R form a triangle. Then this number also has the hence part. They want us to substitute in the formula. The formula is A meaning area, is equal to root of S. This S, they said it is same perimeter. Same perimeter. So it means it is the perimeter of all the triangle. This plus this plus this perimeter. Then half of it is the same perimeter. So same perimeter into, this is S minus A. These ones are sides of a triangle. Then S minus B into S minus C. I will substitute in this one. So the same perimeter is this S. It is the same S here. It is S, 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 S. So which means we have to first get the same perimeter. So same perimeter, the same perimeter S will be equal to, remember perimeter you add this side plus this side plus this side. So on the sides we had P2 plus 2R, then plus RP. These were the sides out of 2. But remember we had the length of P2. The length of P2, if you remember very well, it is up here. It was root 137. Then plus 2R, which was root 98. Then plus RP, which is root of 137. Then all this one out of 2. So you have to put this on a calculator. So when you put in a calculator, it gives you something like 17.68 when you round off to 2 decimal places. So after getting S now, it becomes simple because we already have A, we have B, we have C. So we can call P2 A. We can call, I remember this A, B, C. They are the sides of the triangle. This one can be A, B, C. Remember this one was P, 2, then R. So I'm calling P2 A, P2 A, then 2R B, 2R B, then RP C, then this one C, then this one is B. Okay, then I come and substitute in the formula. You substitute in the formula and you get the answer. So this one is area equaling to root of, now S, remember we had it as 17.68, then into 17.68 minus what was A? A is the length of 2. Length of 2, it is root 137. Then plus 2R. 2R is, remember there is this S here. So again, we again put, do you have plus? No, we don't have plus anyway. It is this. So this one will be 17, which is this S, 17.68, again minus B. B is 2R. 2R was root of 98. Then again into S, which is 17.68, then minus RP, which is C. C was again root 137. Yes. So you put this on the calculator. I hope you know how to paste this on the calculator. So after pasting this, you get the answer. The answer you get will be the area. The area should be in square units, because I didn't indicate for us that this one's centimeters or what. Yes, by the way, here you should have units. Yeah. That is the length, or that is the area of the triangle. So all that was part A, because it had the hence part. Now we are going for part B. So wait for number 10, part B. It is coming in the next video, because I don't want the video to be too long. To not come, it will be taking out of MBs.